Hello everyone. So today's topic is probability. It will be a long video of around one. It will be more than 1 hour video, and we will talk about probability. I'll tell you some theory. We will do some questions, and I hope it's gonna make this session very fruitful. And I hope this session will make you score +4 for a probability question in your JEE Mains. And to strive for those 4 marks, we will work today for more than 1 hour, and let's see if you will be able to score that +4 in your JEE Mains and hope for the best. So today I'll try to cover all the topics. I'll do a lot of questions in the probability video. So it's the first video of probability which I'm shooting, and I hope you will enjoy the session. So talking about myself, my name is Krishvi Srivastava, and you can call me Krishvi. I'm a software developer. I work as a software developer. What I'm doing here is like I like maths from my childhood. So when I was given this opportunity, I thought why to waste this opportunity? You never know what can be the life changing moment for you. So I believe in exploring myself. I believe in exploring the possibilities across the world. So here I am with the today's session of probability. What is the aim? The aim in your life is always to provoke the thought process and break all the barriers of anyone who stops you from growing more any day. Okay, your each day should be your day one in which you are better than yourself. Your competition should be with yourself. Okay, so for anyone who feels demotivated, who feels like he or she is not the one by comparing yourself with the other person, no, you don't need to do that. You just need to compare yourself with the previous day you have lived. Okay, you are better than that day. You are improving, you are growing, and that is what it matters. Okay, you should stay consistent. You should stay disciplined. This is what matters at the end, guys. Because you know what? Nobody is the best. The best person is the one who improves himself, who improves herself by just growing more every day, by just looking toward the possibilities, by just looking to whatever the problems they are facing. Okay, so this is for the intro part. Okay, and I hope it did not bore you by this. Some like maybe some people are saying, oh, some cliche lines, come on ma'am, change yourself. So probability, I have seen a lot of people study probability and they are not able to score the marks. They are not able to get the answer. So, what is the problem? The problem lies in your notes. You don't make notes for your probability. See, chapters like probability, permutation, and combination. What you have to do is you have to make notes. The whole question lies in the notes. What you have to do is you have to divide the questions into the types. Okay, and then you have to figure out which type of question does it fall into, and then you can solve that question accordingly by solving whatever the formula it was into that type. So the first and most important thing about probability and permutation combination is to make notes for it. Okay, now I have told you how to study it, and now we will study some theory, we will study some definitions, and then we will do some questions. The workflow will go like this in the session of today. I hope you will enjoy it. So firstly, what is probability? Any outcome, you know what is probability. Seems like my hand is in italic mode. Okay, so firstly, probability comes number of possibilities. Okay, it is the ratio of the possible outcomes. Okay, so number of possible outcomes upon total outcomes defines the probability. This is how you write it. Okay, so now I'm telling you about some specific terms about the random experiment sample space. You know, sample space is something which you write in the denominator, which is the total number of possibilities. I'll just write definition of every term so that you don't forget it. You can take a screenshot, you can make notes. What I prefer is making notes, because when you make notes, you remember what you are writing. So here we have random experiment as a term. Okay, so I'll just write the definition. The experiment whose outcome, something is wrong with the setup, man. Okay, an experiment whose outcome cannot be predicted, like it is random, it cannot be predicted. as the name suggests, random, there is no certainty. You cannot predict the outcomes. That is what is known as random experiment. Talking about sample space, already told you what you write in the denominator. What is the total number of events, total number of possibilities. Sample space, set of all possible outcomes of a random experiment. The set of all possible outcomes of a random experiment. This is what I was saying, that it is the set of all events that has been occurred. The all the possibilities. You don't have to talk about the favored possibilities. All you need to know is the set of all possibilities, that is known as the sample space. Now, what is event? In the probability, event occurs. Okay, and that is where you need to find out the probability. So any subset of a sample space, that is known as the event. Okay, so what is event? Any subset of a sample space, that is known as the event. Now, talking about the likely events, unlikely events, and going more into the terms, I'll just define some more terms that are equally likely events, the exhaustive events, the exclusive, inclusive. Whenever these terms are used, you don't know how to solve it. So right now I'll define every term to you, so that the terms get clear in your mind and you can solve the question like that. So equally likely events, two events are said to be equally likely events when chance of occurrence one event is equal to chance of occurrence of another event. So when the chances of occurrence seems to be equal to another event, that is where they are known as equally likely events. Now, how we can define this? Exhaustive events. You know about exhaustive? You must have studied mutually exclusive and every term like this. Exhaustive events. So events are said to be exhaustive if nothing else can occur beyond. Exhausting event, that these are the only events that can occur. There is nothing else that can occur. Nothing else can occur beyond them. Union. See, if nothing else can occur beyond them, then that means that union of exhaustive events will make the sample space. What I'm trying to imply is that, if nothing else can occur beyond them, then obviously the union of exhaustive event is equal to sample space. For example, we know that there are only two balls in a bag. So obviously when you are asked that what is the what does this bag contain, then that can only contain those two balls only. Okay, so now what else do we have? We have here is mutually exclusive events. We talk about exhaustive, now we are talking about exclusive. Okay, don't get confused in between the terms. So here we have mutually exclusive events. So two events are said to be mutually exclusive if they cannot occur together. See, exclusive means they are totally different, that they cannot occur together. That is, the intersection of these events will result into null. So mutually exclusive event, exhaustive event, what I told you, that exhaustive event mean that nothing else occurs beyond them. That means that union of exhaustive events will result into sample space. Whereas talking about exclusive, exclusive means excluding. So exclusive events mean that these two events have nothing in common, that they cannot occur together. So that is why the intersection of exclusive events will result into null. Now talking about probabilities, what type of probabilities we have, we can talk about conditional probability So for conditional probability, the probability of occurrence of event A, given that event B has already occurred, the probability of occurrence of event A given that event B has already occurred. So conditional probability, as the name suggests, that the condition has been given and then you have to find out the probability. Excuse me. It's like when I'm talking I get warm, so I need to change this. Okay. The probability of event A that event B has already occurred, that is where it is known as conditional probability. Okay, now talked about conditional probability's definition. Now you will know how to denote it, how to define it. Okay, so the conditional probability is denoted, it is denoted by, okay, this is the probability when event B has already occurred. Okay, now the formula for this is intersection B okay. Now B by A, what is going to be that formula? So whatever comes like B by, you can remember it by B by A. If that is asked, then the denominator is already going to be probability of A. Whatever is going to be in the denominator, that is the probability that is going to be in the denominator. Okay, that is how you can remember it. Okay, now what else? Conditional probability done. What else do you need to know is multiplication theorem and probability. So how do you write the multiplication theorem? That is very simple. You did this formula, that is P A by B and P A intersection B upon P of probability of B. So you can just write it like probability of B into probability when this has occurred is equals to A intersection B. What we have done, just simply transport some terms and write it as the theorem. Okay, this is what the theorem suggests. So now we can write here as P A intersection B is equals to P of A into P of this. Okay, also we can simply, you know it, you know this. How do we got this? We got this by this formula of conditional probability. We got this by the multiplication theorem. We got this by conditional probability. So it's nothing different, just some terms transposed here and there. That is what is changed in the multiplication theorem. Now we will talk about some independent events. So two events are said to be independent if occurrence or non-occurrence of 1, simply as the name suggests, does not affect the occurrence or non-occurrence of other. How it is illustrate? So I'll give you one example. For example, when I'll just write this example, when a coin is tossed twice when a coin is tossed twice, the event of occurrence of head in the first throw and occurrence of head in the second throw are independent events. So, for example, when you toss a coin, you see that you play it like if it is head or tail. But when you toss the second coin, that does not mean that it is related to the first toss. Okay, so nothing is related to the first toss. That is why they are known as the independent events. So whenever you see something, some event that is not related to each other, that is where it is known as the independent events. Like for example, first toss does not affect the second toss. It is not affecting the probability. It is not affecting if it is coming head or tail. Okay, first toss does not affect the second toss in any way. So that is why these events are known as the independent events. Okay, so now what is the note from this? Okay, this is very important thing. So if A and B are independent events, that means probability, conditional probability will be equal to this. Okay, this is why it is known as the, this is very important. Okay, when these event are given independent, then this formula you have to remember that this is what it means. It means that the conditional probability will be equal to the probability of A, because in A intersection B is not going to be anything, because these are the independent events. Okay, now one thing more, that if, and you know this, that conditional probability is going to be this. Now when you are asked the A intersection B, so how you can write this? You can simply write this by multiplying the probability of A and B. That is where you can get the A intersection B, because you know the probability of A, that means B is not happening. Probability of B, that means A is not happening. So how do you find the A intersection B? So if A and B are independent events, then you find the intersection B like this formula. Okay, and also one more keynote, that if A and B are independent events, okay, if A and B are independent events, then what else? A dash and B dash is also going to be independent. A dash, B dash, I hope you know that when A is not occurring, that is known as the A dash. Okay, A dash and B dash, A dash and B, A and B dash, these are also independent events. Okay, now I'll talk about the total probability law. We'll cover the whole probability in this session. And I tell you, the theory is very important for probability as well as permutation and combination. Without covering theory, you cannot remember the questions. So, total probability law. How do I write it? I'll just write it first. Okay, so this was about the total probability law. If you know P intersection B1 formula, then you already know another formula, because P intersection B1 can be written as, what I have done in the second thing, I have just substituted this formula, that was PB1 into A by B1. You know this formula from the conditional probability. So the total probability law define that if an event can occur with n mutually exclusive and exhaustive events, so that means the events are independent as well as the events cover the whole sample space. Okay, so the union of these events will be equal to sample space. So obviously the another probability will be equal to all the other probabilities, that is the PB1 plus PB2 and that thing. So this formula is being applied here, the total probability law, that suggests that probability of A will be equal to the B1 union A, B2 union A. So anything that is union, because that event is covering the whole sample space, so we will take the union from probability of A, from the event A, and that will sum up to the probability of A. So that was the total probability law. I hope you understood this. It is related to the conditional probability. So I have explained you conditional probability, and total probability law must be easy thing to understand by you all. Okay. Now I will write Bayes theorem. So if an event A can occur with n mutually exclusive and exhaustive event B1, B2, B3, this is the formula, the whatever the probability, the conditional probability is in the other side, that goes in the denominator, you already know. This is why I have written like this. Now what else we can write here is probability of A, that you already know the formula by the total probability theorem. So I will write the formula for this, that is B1 Bayes theorem. It's a very important theorem and it is very simple to implement. I will do it in the question, then you will understand this. Here you must be able to, you are not able to understand it because of the conditional probability theorem. It's a very simple thing. All you need to find is that what probability you need to know, and then in the denominator you need to add all the other probabilities as well. Now what else do you need to know? You need to know about the random variable. You know random variable. You know about the probability distribution. Okay. Need to know about the Bernoullis trial. Okay. Mean variance and standard deviation. Okay. Three more things. Okay. Let's just complete that also, and then you should start doing the questions. So, I think I'm just being eager to solve the questions. So I'll write down some more theories. So what is Bernoullis trial? You know the Bernoullis trial, where it is, where does it happen? See, it happens when a coin is tossed, because these two events have the same probabilities, and it is like, the probability is going to remain same. If it is going to be head, if it is going to be tail. Same thing, a arrow is fired, so if it is going to hit or if it is going to not hit. Okay, same goes for a card is drawn with replacement, so if it is going to be ace or if it is not going to be not ace. So whenever we have this thing that if it is going to be or not going to be, just straightforward two answers. Okay, head or tail, then that is known as the Bernoulli's trial. There we can apply Bernoulli's trial. So I will write about firstly the probability distribution, and then I will write about the Bernoulli trial. Okay. Okay. So what does the probabilities distribution says? The probability distribution of a discrete random variable is a graph table of formula that specifies the probability associated with each possible outcomes that a random variable can assume. So it's related to graph, okay, and I hope you have done that, and if you have not done, we will cover this in the question. So this is the distribution theorem. You can take a screenshot or you can make notes accordingly. The probability distribution of a discrete random variable, you know, the discrete values, and it is a random variable in a graph table of formula. So you can find out the probability but in a table, in a graph, in a formula, and it just have to specify the associated probability, and then at the at every outcome you can assume that random variable, and then you can find the probability. So at every outcome the random variable can be assumed to be the same. And this was it about the probability distribution. Now coming to the Bernoulli's what it was, Bernoulli's trial, and after that some probability distribution formula. So probability distribution I've completed. Firstly, I'll write some formulas for that. That is about the mean. Sometimes this question comes straightforwardly. It's like a bonus to you all. Mean, variance, and standard deviation. Whenever this question gets asked, all you need to do is just apply the formula and analyze which value should be substituted to which variable. Okay. So I'll write down the formulas. So mean n Okay, so what is the mean formula and what is the NPQ? N is the number of trials, number of events. P is the probability of success. Q is the probability of failure. So if you know P, you know P is equals to 1 minus Q. That also you can do in some of the questions. And these are the formulas for mean, that is the NPQ. And now you know the standard deviation, that is the under root NPQ. This is a very important, these are very important formula, and sometimes question comes straightforwardly without any if and but. So all you need to do is just apply the formula and get the answer. Now adding some more content here. So what do we write here is the Bernoullis trial. So a trial, obviously, I told you like a coin, a toss of a coin. Like an arrow is fired if it is hitting or not, if the head comes or not. That is what sometimes the events are called. So a trial having only two possible outcomes, that is known as the Bernoullis trial. Okay, having only two possible outcomes, either head or either tail, either hitting the target or not hitting the target. Okay, these are some possible outcomes. So let probability of success is equals to P, whereas probability of failure is going to be equal to Q. P plus Q is equals to 1. This is but obvious. So now one thing more, that if this experiment, sometimes this gets added to the question and people lose their mind. So a trial having only two possible outcomes, that is covered in Bernoulli's trial. Probability of success, it's going to be P, and P plus Q is going to be equal to 1 because these are the only two possible outcomes. Now in the experiment with same probability is repeated n times, the probability of R success, that means R success out of n is going to be NCR. Simple formula, P to the power R and Q to the power n minus R. This was it about the theory, probability. What were the things that we covered? I'll just give a brief recap and then we'll start doing the questions. So firstly, we talked about random experiment. When an event occurs randomly, we cannot predict like what outcome it is going to be. Sample space, we know that set of all possible outcomes of a random experiment. Even is event is any subset of that sample space. Okay. Now equally likely events, two events are said to be equally likely when chance of occurrence of one event is equals to another event. Exhaustive event, if nothing else can occur beyond them, exhaustive event. Okay. Now, mutually exclusive, if they cannot occur together, that is the intersection of these events will result to null. Conditional probability, the probability of occurrence of event A given that event B has already occurred. So when how do we donate it? Where B has already occurred and we have to find the probability of occurrence of event A. Okay. What are the some basic formula, that is P intersection B upon probability of B, whatever it comes beside this, that goes into the denominator. Here it is and there it is. You can remember it like that, the formula. Okay. And multiplication theorem, all you just need to do is just transport the variables here and there and you will get your multiplication theorem. And what is the event independent event says? The independent event says that two events are said to be independent if occurrence or non-occurrence of one does not affect the occurrence or non-occurrence of other event. So for example, you toss a coin and then you toss another coin, so that is not affecting the other event. Okay, you are doing the same process, but that is not going to affect any process. Now a simple thing, that is what I have written, that when a coin is tossed twice, the event of occurrence of head in the first row and occurrence of head in the second row are independent events. Now if A and B are independent events, that is what we can write. This is how the formulas can be written as total probability of law. You know total probability law, this thing you knew the formula by conditional probability. You know now P, probability of A, you can write it like this. So if an event can occur with n mutually exclusive and exhaustive events, so all these events are exclusive and or exhaustive, that is why we can write it like that. Now we know A intersection B1 can be written as this. So what we did is just did another form, we just use this formula, that was it. Now we will talk about Bayes theorem. Bayes theorem suggests that whatever it is given the favorable, that upon the number of probability. For example, you were given the probability of finding the red ball in the balls of black, green, blue. So what you will do is finding the probability of red ball in the in the bag of black, red and green. So how you will calculate is you will find the probability of R and then you will calculate the probability of B plus R plus G. That is what is going to happen when you will calculate the probability of red ball using Bayes theorem. Similarly, the other questions as well that you can do by using the Bayes theorem. It is a very simple theorem and you will be able to enjoy the question as well as get the correct answer for this. Okay, so giving you the example of also the Bayes theorem. Now moving forward, you have Bernoullis trial. So a trial having only two possible outcomes, like probability of success or probability of failure. Okay, so a trial having only two possible outcomes. So obviously P plus Q will be equal to 1. Now if this experiment with same probability is repeated n times, okay, so the same experiment is repeated n times, the probability of R success is going to be NCR P to the power R Q to the power n minus R. Simple combination, simple formula. We have also did some formulas like this in binomial theorem. I hope you have seen that video and then you have come to this video. So if you have seen that, then you already know this formula. It's very simple for you all. You knew the probability distribution law, and from that we got to the mean, variance and standard deviation. So when n is a number of events, p is the success ratio, then how can you can calculate the mean, that is n into p. How you can calculate a mean, that is n into p into q. But when you talk about the standard deviation, then you take the under root of that mean, that is under root npq. So whatever you did in the mean, you took the under root and then you got the standard deviation. Now n, what is n, what is p and what is q? N is the number of fixed trials. Okay, now what is p? P is probability of success, okay, in one of the n trials. What is q? Probability of failure in one of the n trials. Okay, q is the probability of failure in the number of trials. Okay, and p is number of success. So this was it for the theory. Now we will start doing some questions. There's a very big question. I'll just write a small question. So this is the question from JEE Main's 3rd September 2020. Okay, so the question looks like, Okay, this is the question. This is the question. A pair of dice is thrown and sum of dice comes up multiple of 4. Then find probability that at least one dice shows 4. So pair of dice means, that means 2 dice. Okay. Now multiple of 4. Okay. So a pair of dice is thrown and sum of dice comes out to be multiple of 4. Multiple of 4, you understand what can it be? It can be 4, 8, 12, 16. So for that, one dice has to be the multiple of 4. Okay. So one dice has to shows 4. That is how it can become the multiple of 4. That is how that sum of dice comes up multiple of 4. Okay. So for A, let me change the color of the pen. So here you can see A, you can consider it as multiple of 4, and B, at least one dice shows 4. Okay. So how it can be possible? It can be possible 1 3, 2 2, 3 1. Okay. Is it possible for 4 1? No. 1 2 3 4 4 2, no. 4 1, no. 4 3, no. 4 4, yes. 5 1, no. 5 2, no. 5 3, yes. 3 5, possible, yes. 5 3, now we talking about 6 1, no. 6 2, yes. 6 3, no. 6 4, no. 6 5, no. 6 6, yes. And 6 2, it goes 2 6. So these are the favorable. Okay, these are the favorable. Now what it is said that find the probability that at least one dice shows 4. Okay, one dice shows 4. So that means this is the dice that shows 4. So what are the number of possible events? 1 2 3 4 5 6 7 8 9. And which dice shows 4? 1. Okay, so 1 upon 9. That is going to be the answer. Simple. All you need to know is a pair of dice is thrown and sum of dice comes up to be the multiple of 4. So how it can be possible? We just wrote the number of possible sum of dice that can be the multiple of 4. That is 1 3 this. And find the probability that at least one dice shows 4. Okay. So the one dice is showing 4. That is only happening once. So that is going to be the answer. That is 1 by 9. These are 9 events at which the sum of the dice is going to be the multiple of 4, out of which only one event has occurred in which the one dice has the in which one dice phase shows 4. So that is why the answer is going to be 1 by 9. Okay, another question. Very long questions, very long question. The question seems to be long in the probability, but it is not long when you solve it. Okay, the solution is not that long. All you need to do is you just need to understand the question. You need to know that what is the question asking. Okay, okay. So we have this question. One more question about dice. So for this question, we have 4 pair dice are thrown independently 27 times. Then the expected number of times at least 2 dice show up a 3 or a 5 is. Okay, So here what we have is 4 fair dice are thrown independently 27 times. Then the expected number of times at least 2 dice show up at 3 or 5, at least 2 dice. So out of those 4 dice, at least 2, that means maybe 3, maybe 4. Okay. So what you can do is here, you can easily use the series that I have told you. So for the probability that at least 2 dice show 3 or 5, we can write it as we have 4 dice. Okay, so what can be the probability? The probability is maybe 2 4 C2 2 by 6. So because here we expect 4 dice, and here we can expect that there are 6 total possible outcomes. So for 4 dice, at least 2 dice show 3 or 5. So 3 or 5, that means that one dice can show 3 as well as 5. So that will be 2 by 6. Another dice, that is going to be 4 by 6. You know the formula for it, that is NCR TR Q N minus R. So this is the formula which we have used here. Okay, plus 4C3, here 2 dice, here 3 dice. We are talking about 3 because we have at least 2. That means there can be 2 3 4. Okay, the at least means 2 dice, 3 dice, or 4 dice. Okay, 4C3, 2 by 6, 3, 4 by 6, plus 4C4, 2 by 6, 4. So this is how we can find out the probability that at least 2 dice show 3 or 5. That means at least 2. So at least 2, at least 3, and at least 4. So at least means that minimum 2, and maximum it can be already, because we have 4 dice, so it can be 2, 3 as well as 4. So how do we calculate it? I'll just write the values. So the answers comes to be 11 by 27. Now, do you know the formula of NP? That is the expectation of number of times is NP. You know the formula of NP, you know the formula of NPQ. So the answer is going to be, what is going to be NP? So N is basically the total number of times, that is 27. What is the probability coming out to be? That is 11 by 27. So what is going to be the answer? The answer is going to be 11. Okay. So how did we do it? Sorry. So how did we do it? We did it by, two, at least 2 dice asked. So 2 3 4 done. We calculated the probability. Now what was asked? That the expected number of times. So how do we calculate the number of times? Here it is not asked the probability. The thing which is asked is the expected number of times. So how do you do it? You do it by multiplying it by the number of times the event has occurred. So the number of time has been given 27. You just multiply it by the probability and the denominator, and you just calculated this. Luckily the denominator and the n was same, so we just got the value, that was 11. The calculation did not get tough. Sorry, just getting late and I feel dizzy. Okay, so also I have to complete my other work as well, so I'm a little tired, I'm sorry. Now how do you do it? Another question, let me see one more question for you all. Let's just do something different this time. Okay, okay, this seems tough little. Let's see. Okay, the question is the probability that a randomly chosen 5-digit number is made from exactly 2-digit. Okay, so here we have the probability Here we have the probability that a randomly chosen 5-digit number is made from exactly 2 digit. Exactly 2 digit. That means we can only use 2 digit in a 5-digit number. That is, we have 5 spaces, 1, 2, 3, 4, 5. And what we can do here is we can only use 2 digits. That is, like, just assume that x and y are digits and we can only use 2 digits. X and y can be any number. So two numbers can be only asked. So how it is possible? It is possible. What will be the total value of this? The total value of this is obviously going to be, what is the total number of digits that can be occurred? That is 9, because we have 1 2 3 4 5 6 7 8 9. So we have 9 digits here. Okay, and now we have 1 2 3 4. So what you can do is, I'll just write how you do this question. See, what you can do is, it is obviously repetition is allowed because only two digits are asked, so repetition is allowed. That is but obvious. Okay, so in the first block, can you write 0 here? No, because if we write 0 here, that it becomes 4-digit number. So what you can write here is 1 2 3 4 5 6 7 8 9, 9 digits. But here what you can add here is 0 also, because here you can add 0 and you can repeat also. So that means you have all the 10-digit numbers. Same here, because repetition is allowed, so we can write here 10. Same here, we can write here 10. We can write any number among all those 10 numbers, because repetition is allowed, so you don't care what the first box is constituting of. So you can easily write any of the 10-digit numbers. So what is the option? What is the total number of ways? 9 into 10 into 10 into 10 into 10. So that goes 10 to the power 4. So that is the total number of ways. Okay. Now, probability that a randomly chosen 5-digit number is made from exactly 2-digit number. So now you have to answer the favorable outcome. Okay. So how you can do it? You can do it if 9, in this 9 digit number, you can choose 2-digit number. Okay, you can use two numbers from those 9. Okay, so 9 C2, and what is the answer that is left? That is 2 to the power 5 minus 2. Okay, plus what else you can do here is, you can use here 9C1, because here you have already used one number. Now you can use another number, because it is asked that 2 digit. Okay, so here you have written 9C2, you had option of 2. Here you can use only one number. See, let me tell you something. 9-digit number from 9 numbers, that is 1 2 3 4 5 6 7 8 9. Out of all these 9, you have to choose 2. You have options of choosing 2 here. Okay, now from choosing 1 here, what you have here is, you can use here 0, but one digit is already being used here, so you can only choose 1 here, and you are only left with 9-digit number, because you are subtracting the 1-digit number that is used in the first form. I hope this is clear. See, in the first block, you have used that number. You have used that number. So you are excluding that number. I don't know which number it is going to be. So you are excluding that number out of 10, and you are including 0 here. Okay. In the first number, you were not including 0, but here you were including 0. So the 9 remains same. But now you are only needing one number. So you have here 9C4, and it goes 2 to the power 4 minus 1. Okay. Now all you need to do is, you just need to solve the question. The value comes out to be, this is how the favorable outcome is going to be looking like. So you can just solve the question and you can get the answer. Now going to the another question. So going to other question, we have the probability. Let me see another question. Okay, this is the same question. Okay, let's just do one question of hitting targets. I'm writing the question first. Okay. See, first thing, it is talking about hitting a target, and I have already told you in the Bernoulli trial, whenever you have such events of hitting a target, if it gets it or if it is not getting hit, okay, same goes for the coin. Whenever you have something which only have two events, then that is why we can apply that Bernoulli trial, which was using the terms of P and Q, okay. So I'll read the question. The probability of a man hitting a target is 1 by 10. The least number of shots required so that the probability of his hitting the target at least once is greater than 1 by 4 is. So here what we have here is P is equals to 1 by 10, because this is the hitting of target. This is the success trial, 1 by 10. Q, what is going to be Q? Q is going to be 9 by 10. So probability of not hitting in n trials looks like 9 to the power 10 by n, because not hitting is asked, and this is the uh, probability of failure, okay. So 9 to the power 10 n, and now at least one hit, because at least once this is asked. So at least one hit, how you can calculate at least one hit? By, see, at least one hit, at least two hit, at least n hits. And what can be the probability if you can calculate at least one, at least two, at least three? See, at least one means one, two, three, more, maybe more than one. So what you can do is you can easily do total number of probability minus not hitting. Not hitting, that will give you equal to the number of times it is hitting the target. So using that formula, 1 minus 9 to the power 10 by n. So this is obviously at least one hit, that is 1 minus not hitting an end trial, that is hitting the trial. They're giving the probability of at least one hit, at least two hit, at least the n number of hits, okay. So what do we have here is, see, you are giving, you have calculated this, but according to question, it is greater than 1 by 4. So according to question, 1 minus 9 to the power 10, 9 by 10 to the power n is greater than 1 by 4, is greater than 1 by 4. So solving it, we got signing change because we are using minus here. So 1 minus 1 by 4, we got 3 by 4, and we have transport the minus, so sign has been changed. Now we have 0.9 the power n, and we will solve 0.75. Okay, we got here 0.75. So how you can get the value of n? You can just compare, you can just make the base easy, you can try to make the base easy, base same. So when you make the base same, you know that okay, what you can do here is, you know, 3, you can make it as 0.32n, and you can make this also to the base. So that is how you will get the value of n is equals to 3, and that will make up equal to 0.729, 0.75. So n is 3, so this is how you got n. 0.75 is greater than 0.729, so this is true. So that is why the answer is going to be true. I hope this was clear. This was very easy when you know the P and Q trick. If you know the Bernoulli's trial, if you know when hitting the target is required, then you can easily apply that thing. So doing one more question. Let's do something else, a different question, and I hope you will enjoy that question as well. These were all the past year JEE questions, FYI. So if anyone is saying of different level of any other level, then this is the past year JEE question. I did not define the level. Okay. Now we have this question. Where did I keep that question? Okay. Okay. So now we got, okay, this question comes a lot. Let's just do this thing. And it is a very basic question. I don't know why people leave this. So what is the possibility of having 53 Thursdays in a non-leap year. I think all of you must have seen this question till now. Okay. So now, what is the probability of having 53 Thursdays in a non-leap year? First of all, you know you have 365 days in a year. Okay. You have 365 days in a year. Now, how you can find how many number of weeks? You can just divide it by 7. And now you know we have 7, 7, 2. Okay. So we have 52 weeks in a non-leap year. Okay. So what do we got? See, 7 divided by 365. What do we get here is uh, so 1 day is left. Okay, 52 weeks. That means 52 Thursdays is a must. That is for sure. Plus 1 day. Okay. Now, what can be this 1 day? This 1 day can be anything. This 1 day can be Sunday, Saturday, Monday, Tuesday. This 1 day can be any of the day among that days of week. So, how many days of week it is? 7. And what is the probability that for 1 day is going to be Thursday? The probability is only going to be 1 by 7. Okay. This is similar. Any days asked, 1 by 7 is going to be the answer. If any days asked at 53 Thursdays, that means 52. It's normal. We have 52 Sundays, we have 52 Mondays, we have 52 every day of the week in an year. Okay, non-leap year. And now when it asked about Thursday, you know 1 day is left. Okay, now 1 day is left. So what it can be? It can be any of the 7 days. So that is why the probability is 1 by 7. Now doing one more question. This is going to be the last question. We are applying Bayes theorem here. Okay. Okay. It will be a lengthy question. I'll just write the question first. So this question says a box has 6 black, 4 red, 2 white, and 3 blue shirts. What is the probability that 2 red shirts and 1 blue shirt get chosen during a random selection of 3 shirts from the box? See, there is only one box, so we don't need to choose any box. We only have to work with the shirts. So, what it can be? What is the probability that at least 2 red shirts and 1 blue shirt? 2 red shirts, at least. What is the that 2 red shirts? What is the probability that 2 red shirts and 1 blue shirt get chosen during a random selection of 3 shirts on the box? So what it can be? 2 red shirt. How you can select it? 2 red shirt and 1 black shirt. Okay. What can else it be? It can be 2 red shirt. It can be 3 red shirt. There's something I'm missing. What is the probability of 2 red shirts? What is the probability? What is the random selection? Okay, no, this is it. Okay. 2 red shirt and 1 black shirt. What is the probability that 2 red shirt and 1 blue shirt get chosen during a random selection of 3 shirts from the box? Random selection of 3 shirts. So how the 2 red and 1 black can be selected? See, what can be the different ways? It can be R, B, R, can be R, R, B, it can be B, R, R. Okay, this can be this. Or these three can be the selection of ways. Okay, so how you can select it? RBR. So selecting red shirt, one red shirt from four red shirts. So what do we get here is, see, what is the total number of shirt? That is 6 plus 4 plus 6 plus 4 plus 2 plus 3. So that comes to be 15. Okay, now you have to select the red shirt. Okay, red shirt, that is four red shirts. Okay, you have four red shirts. So what do we get here? 4 upon what was the total count? That is 6 for 2, 10 to 12, 15. Okay, we have total number of shirts. Total number of shirts 15. So 4 by 15 into, now what we get here is black. We have to choose the black shirt. What is the is it black or is it blue? It's blue. Okay, 3 is the number of blue shirts. 3 is the number of blue shirts. Now what we get here is 3, and what is the number of shirts already left? Because we have chosen 15, we have 14 here. Now what is the red shirt? We have already chosen one shirt from that, so 3 number of shirts are left. Now what is the number of, okay, or wherever you one thing more I have to tell you. Whenever we have or in a term, that means plus. Whenever we have and, that means multiplication. So whenever we have or, we use plus. Whenever we have and, we use multiplication. Okay, now when we have to choose red shirt, whenever you have to choose red shirt for the first, then you choose 4 by 15 again into 3 left, 14 into black, blue, it is 3 by 13 plus, now you have to choose blue first. Okay, 3 by 15 into red. What is the red? 4 by 14. One shirt chosen from the red, 3 shirts left, and already 2 shirts are being chosen, so 13 is left. Okay, so this is the term. This is how you're going to solve the question. Now how you can easily calculate this? I'll do one calculation too for you all. You don't have to solve each term, just think how you can solve all these terms. See, the denominator is same, so how you can do it? 15 into 14 into 13. We have 4 into 3 into 3. We have 4 into 3 into 3. 3 into 4 into 4. Same term, same term. So that is 4, 4 2s are 8, 4 3s are 12, 12 3s are 36. So we have 36 3 times. We can use 36 into 3. Okay, that is it. Solve it. 3. Okay, and how do we get it? Okay, so this is it. We got our answer, that is 18 by 35 into 13. You can solve this thing. 13 5s are 65, 13 to 65, 13 is 39, 39 plus 6 goes to be 45. So 455, 18 by, okay, so this came out to be the answer, that is 18 by 455. I hope you have understood this thing. And one thing more, which was very important, which I told you in this, so that was that or is, whenever or is used, you have to use the plus thing. Whenever and is used, you have to use the multiplication thing. Okay, red and black and red shirt, we used multiplication. These were three different ways, maybe first way, maybe second way, maybe third way. Okay, so maybe the first way or the second way or the third way. So we had or, so we used plus there. You have to remember this thing. Whenever you have the or option, you have to use plus there. Whenever you have the and, you have to use the multiplication there. Okay, so here I'm writing it once again. Whenever and is used, you use multiplication. Whenever or is used, you use addition. These are the two things which are definitely being used, and this helps you in the question a lot. Whenever and is used in the question, you have to use the multiplication sign, sign. Whenever or is used, you have to use addition sign. Okay, that is it. And let's do one more question. Okay, so doing one more question we have here is, okay, sure, it's done. Dice, a lot of question have been done about dice. What you can do here is, No, 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 no. Okay, let's just do this question. Here and or is used. So you remember and multiplication or addition, okay? So I'm writing the question. The question looks like there are two pots, okay? There are two pots. One pot has, I can't see the question. One pot has five red and three green marbles. Another has four red and two green. What is the probability of drawing a red marble? See, here simple and straightforward. One pot has this, and another has this. Whenever you have these things that one has this, another, and one thing is being asked, Bayes theorem. This is being used here. Okay, now you have two pots. So first pot, firstly you will choose there is nothing given about the pot, so you will just assume that one pot has five red, three green, another has four red, two green. Okay, so either you choose it from first or you choose it from second. Okay, so first the number of the, see, what is the probability of choosing a pot in between two pots? That is 1 by 2. Simple. We have two pots, you have chosen the first pot, you have chosen 1 by 2. Now you have to choose of drawing a red marble. So what is the probability of drawing a red marble? That is 5 red. And what is the total number of marbles in the first pot? That is 8. Plus you have or here, you have used, maybe Bayes theorem has not been used, it's like straightforward question. One thing is sure, whenever you have or, you used plus. Second, you have chosen the second pot, you have drawn the red marble from the second pot, that means you have chosen the second pot, so the probability of choosing the pot is going to be 1 by 2. Now you multiply it, and now you get the probability of drawing a red marble. So 4 red, that is 4, and now you have 4 plus 2, 6. Okay, so 6 marbles on total. So this is going to be the probability. It is going to look like, okay, excuse me guys. So two pots, one is obviously the focus was on red marble, you have to choose the red marble. So out of the pots, you have to choose in first pot, then the first pot probability was 1 by 2. Now red marble from that 5 by 8, the total marbles were 8 and 5 were red. Another pot 1 by 2, 4 marbles were among that and 6 were the total, so 1 by 2 into 4 by 6. And or obviously we have used the add in between, and we have calculated. I have solved the algebraic part too, because some people say that I leave the algebraic part, so I did the part on myself by myself. Okay, it was very tough, no? Okay, so that is it for today guys. See you soon. I hope you have enjoyed the probability session. I had covered all the theories, I did all the questions, I tried to cover different topics, the dice part, the toss part, the hit part, and every type of questions. So this was it for the probability. For any further updates, write down in the comment section whichever part you need to know about the probability. I will cover those topic also. And what is the first thing you need to do in the probability? You need to find which type of question is being asked, which formula will be applied in that formula, that in that question. Okay, that is the key to solve the probability as well as the permutation combination. Just try to find which type of question is it, and then solve it accordingly, whatever it is given. If you have been able to analyze the question, 50% of the question has been completed. 20% of the part is algebraic part, 30% of the part is to apply that formula, if you even remember that formula or not. And that only comes within the time. You can do it, but it will require a lot of time. So for reducing the time which is being used to solve the question, you can do is practice. What you can do is practice, because practice makes you perfect, and when you are perfect, you will use less time to solve the question, and when you're using the less time, you are having a lot of time in your JEE Mains. So time is an important factor in your exam. Just remember this thing. You cannot invest a lot of time. You cannot invest total 10 to 5 to 10 minutes. No, you can't apply that to a single question. You have to do whole paper. You have to apply maths, physics, chemistry as well. So just try to be very fast and quick and accurate, and accuracy comes by perfection, and perfection comes by practice. So start practicing, guys. I hope you have enjoyed the session. For any more further details, you can just go to our Telegram channel and look on the further updates. And for any advice, for any feedback, you can just put down on the comment section. You can also like the videos. It's free of course. Just subscribe to the channel, like the video, and see you soon, guys. I hope you are taking care of yourself, and take care, rest. See you soon, and stay healthy. Bye bye.